Hello everyone. In the previous video, we have discussed about maximum power transfer theorem. Explain that is a statement, explanation of maximum power transfer theorem, and also application of maximum power transfer to the electrical circuit. In this video, we are going to discuss about substitution theorem. Okay, so this is also a very important theorem in network analysis. Okay. This is the recap, already we have discussed. Now, after completion of this video, you will be able to state the substitution theorem, explain the substitution theorem, and also apply the substitution theorem to a given circuit. So these are the outcomes you will get at the end of this. Okay. Now this is from known to unknown. Already we know few things. Unknown thing, that is a substitution theorem. How to find out, how to apply these things from known things to unknown value, and we can find out. We have already discussed these things, right? Many laws, Ohm's law, KVL, KCL, different theorems are available for solving networks. Some of them already KCL, KVL, loop current method, superposition theorems, Norton's theorem, etc. Many theorems already we have discussed. Right? So it is also one of the theorem. Now, substitution theorem states that if an element in a network is replaced by a voltage source whose voltage at any instant of time is equal to the voltage across the element in the previous network, then the initial condition in the rest of the network will be unaltered. Okay, so that means here an element in a network, that is one element is replaced by voltage source. So whose voltage at any instant of time, at that voltage is equal to voltage across element in the previous network, actual network. So both should be same, that is the meaning. But only condition here, it is initial condition in the rest of network will be unaltered, no change in that. Those are fixed conditions. Okay. Same statement we can give in another way, in simpler manner. So that we'll see now. Okay. Or substitution theorem again states that alternately, if an element in a network is replaced by current source at any instant of time is equal to the current through the element in the previous network, then the initial condition in the rest of the network will be unaltered. So that means here we have two statements here. Either that element can be replaced by voltage source, or same element can be replaced by current source. Okay, if you are replacing by voltage source, so at that time whatever the value you are finding, okay, so voltage at particular instant of time is equal to actual network voltage, that is a voltage across the element in the previous network. So initial conditions in the rest of the network will be fixed, no change in the initial conditions. Similar way, if you are replacing by current source at that time, so the current through particular element, that is equal to previously without changing, that is general, that is a actual circuit. At that time, what is the value, that should be same. Okay, that is meaning of this. Now we will see how it is. So how to apply this theorem to the circuit. This is the explanation of substitution theorem. Now you see, this is the circuit. Here we have only one source. Remaining three resistors are there, R1, R2 and R3. Right? This is the source here. So this is the entire current. Now this current is divided into two parts here, I1 and I2. Now what the statement gives. For example, if you are taking this branch here. In this branch, the current is into here, right? Now this element is replaced by either voltage source or current source. This current should be same only after replacing by voltage source or current source. This current in this branch, it should be same. If it is changing by the voltage source, at that time this value also it won't change. Particularly here, suppose if you are replacing with by voltage source, at that time how much current, how much voltage, but that voltage it should be same as previous one. For example, here it is V3. So after replacing with the voltage source also, this voltage should be equal to that only V3. Similarly, if you are taking that is replacing the current source, at that time how much current it is flowing. So that value it should be equal to actually now the current how much it is. It should be same. Okay. Now this is the current I is flowing through the circuit, which is divided into two parts here. Already I have shown I1 and I2. Okay. I1 is flowing through the resistance R1, I2 is flowing through the resistance R2. Vs is the source and V1, V2 and V3 are voltages across the resistance R1, R2 and R3. These are the simple explanation of about the circuit. Now we'll see here, if the resistance R3 is substituted by voltage source, how the circuit it is. Now you see the circuit, this is the circuit. Now we are replacing R3 element by voltage V3. Okay. Now if I am taking that is another already it is there. It can also be replaced by current source, that is I1. Here you can see another circuit, that is okay, either voltage source or current source. In this way you can, anyone you can take. There is no problem for that. So both are same theorem statements only. Okay. In that way we have to take. Now we'll see here, in both the cases shown above, if the element is substituted by voltage source or current source, then also initial conditions of the circuit does not change, does not alter. It won't change initial conditions. Whatever the changes, whether you are changing by either replacing by voltage source or current source, then also initial conditions won't be changed. Okay, does not alter. This means that voltage across the resistance and current flowing through that resistance unaltered even if they are substituted by other sources. That is meaning. Whatever the branch you are taking, those values should not change. That is the meaning of this. Initial conditions of the circuit does not alter means. So if you are replacing by voltage source or if you are replacing by current source, so previous actual resistance at the time, how much values you are getting, whether it is currents or voltages, those values it won't change after replacing the sources also, either it is voltage source or current sources. That is the meaning of this. Okay. Now we'll see how it is by using with an example. This is the first example we are taking here. For your understanding, we are taking simple example. That is generally we are taking practical example. for your clear understanding. Okay, let us take one circuit that is shown in figure D here. Okay, very simple circuit. So one source, 2 ohms resistor, 3 ohms resistor. It is a simple series circuit, right? 2 ohms and 3 ohms are connected in series with the source 10 ohms. Now, already we know, we are taking here 3 ohms resistor. In that place, either you change by resistor, sorry, you can replace by voltage source or you can replace by current source. Okay. Just observe that one. Now you see, this is the condition. Okay. As per the voltage division rule, voltage across, because before doing that, first we will see what are the values of this. Before doing, what are the values of this? Because after replacing this resistance by either current source or voltage source, you will get the values, right? So those values should be equal to actual values. That's the reason we are finding here for checking purpose first. Now how you will see here, you can take either directly, it is a very simple circuit, we can take directly what is the value of current and voltage. Individually you can take because it is a series circuit, it is a simple series circuit. How much current it is flowing directly you can find out, 10 by 2 plus 3, so that is a 2 amps, right? So after knowing the current, so here it is a series circuit, current is same, only voltage is dividing. If you are taking this, the V1 is voltage across this and V2 is voltage across this one, so 10 is equal to V1 plus V2, right? So how much V1? I into R, again by using Ohm's law only. Already we found this is 2 amps because 10 by 2 plus 3, right? That is a 2. 2 into 2, that is a 4 volts across this resistor, and 6 volts, 3 into 2, 6 volts across this. 6 plus 4 is 10, right? So you can go for the direct calculation, very simple circuit. So or you can go for the voltage division principle also. That is, this is the voltage division principle. In that way also you can find. That is your convenient. Which one it is easy for you, you can go for that. Directly I mentioned here, so current directly you can find out. You see here, I equal to current through the circuit, because of series circuit, same current flows here. So 10 volts supplied by this one, that is a 2 plus 3. We got 10 by 5 is 2 amps. Okay, 2 into 2, 4, 3 into 2, 6. You see here, by using this voltage division also we can take that. So here actual total voltage into, so if you want to find out this one, how much will, this is a 3 by 3 plus 2. If you want to find out here voltage across this one, what you have to take total voltage into, so opposite, generally here it is like that. So 2 by 2 plus 3, again you see here 6 volts and this. Or already you have discussed here how to find out the results. After finding this one first, then you can take what is a V3. So that means voltage across 3 ohms resistor directly. I is how much? 2, and that is a product of 2 into R. What is R here? So again 3. So that is equal to 6. You see here, got 6 directly. It is very simple only. If it is a complex circuit, at that time you can go for the even voltage division principle. Similarly, you can find out V2 also. How we can find out here V2? That is equal to, so again, what is the IR? I is again 2 only, because of it is series circuit, and this one it is again 2. 2 into 2 is 4. So this is 4 volts. And this is also 6 volts. You see here, we got again V3 is, V3 means voltage across this one. V2 is voltage across this resistor. Okay, in this way how to find it. This is the first one, actual circuit. Now after replacing this resistor by either current source or voltage source, we will see how much value it is, whether you are getting same value, because as per the theorem you have to get same values. That we can check now. Now you see here. So if you replace 3 ohms resistor with a voltage source of 6, because already we found that one, in place of that we are taking only 6 volts, that is shown in this figure. You see here. Now we are remove that one. Which one? The resistance. In place of that we have taken 6 volts. So this is again simple circuit only here. Okay. So directly 10 minus 6 by 2. How much will get? Current will get. Right? In that way how to, we can take nodal voltage here, directly here and this. Okay, this is one node, this is another node. How much current it is flowing here? So 10 minus 6 by 2. V1 minus V2 by R, right? So same way, we will get this one. After getting that, 2 into 2 is 4. That is the value. Or directly 10 minus 6 is, because it is a total. So this minus this is equal to this. That also we can find. Okay. Now you see that according to Ohm's law, voltage across 2 ohms resistor and current through circuit is, you see here, voltage across this, that is a 6, sorry, 10 minus 6, that is a 4, and current is 10 minus 6 by 2. This got same values, right? That is. We'll see another one. Here we are taking, that is a replacing resistance by which one? Current source here. How much current source you are taking here? 2 amps, right? Because already we found that total current it is a 2 amps only. Now you see the circuit here. Okay, this is the circuit. Now you see this is the current. So this one it is a current. How much? So that is 2 amps. Okay, this is the 2 amps current here. This is, that is the resistance is replaced by current source here in this direction. Now you can see here, so this is the resistance, already it is 2 ohms. Now find out the values again here, how much value you are getting here in a simple manner, because already this value current source, so this is the 10, this value already it is 2, right? You can just check it how it is. Voltage across 2 ohms resistor, you need to find out the how much, 10 minus. So this already we know, this one we know already here. How much value here? Resistance actually it is 3, right? That is replaced by this one. 3 into 2 is 6. 10 minus 6 is again 4. This one. Voltage across this one. Okay. Voltage across this one is 4. Now after getting that one, this minus this is this. Voltage across 2 amps current source is V2A, that is 10 minus this with this. Now you can see here we got the values here. In this case, in this how much value it is, again 6 only. So we got the value here 4 volts. So here also in this case how much we got, again it is a 4 volts. Okay. So in this way you can find out in the both the cases we are taking here voltage value, right? Voltage and current, both the cases to observe this. So there is no change after substitution of resistance, that is element we call, right? So resistance is replaced by either voltage source or current source. So there is no change in the current or voltage across this one. Current through this resistor and voltage across this resistor in both the cases, this case as well as this case, no change at all, right? So same values only we got. what actual circuit it is, same values only. So that is nothing but all the initial conditions of the circuit is intact, no change at all. Those are fixed values. Whatever the values actual circuit, after replacing these sources also, it won't change any value in the circuit. Okay. So thank you for listening. Till now we have discussed about substitution theorem, statement of substitution theorem. We have taken two statements here. One is okay, and second one is one by element replacing by voltage source. Second one element replacing by current source. And next we have discussed about explanation of substitution theorem, and finally how to apply this theorem to the electrical circuits. Okay, in this way we have covered these three topics in this video. Okay, thank you for listening.